Hello everyone, now I'm doing homework D.6-5. Okay, so here we can see this composite area, an L shape. In order to do it easier, we're going to separate it into different areas. This rectangle that has height of 6, and the base that is the thickness of these, which would be 1 inch. And this other rectangle would be base of 5, right? Because we were subtracting 1 inch from here, and the height of 1. All right, so the center is in this point where we can see the axis 1 and axis 2, right? And so the area of that rectangle, the first rectangle would be 6. The area of the second rectangle would be 5. The sum of the areas would be 11. Okay, I'm gonna put that here so we can have it present. Okay, sorry about this. This was a typo from my part. I cut something I shouldn't have cut. Okay. Anyways, let's continue. So as we can see here, the area of the rectangle 1 is 6, the area of rectangle 2 is 5, the area total is 11. Okay, so with the first moment of area with respect to the x-axis is the sum of the y primes times the areas. Okay, so we need to find this. The sum of the y primes with respect to the areas. Okay, so for the first area would be y1 times area 1, and for the second area y2 times area 2. We're having q1 equals y1 a1, which would be 3 over 2. That would be this height, right? And times the area 6, and the other would be q2 would be y2, which would be 3, what? Okay, so here there's a typo. Sorry about this. The area is 5, and this would be 1/2. Okay, so I'm just gonna erase this, and I'm going to put it back as it should be. And Q2 would be equal to 3 times 0.5 times 5 should be equal to 2.5. Perfect. All right. Inches square. All right, so now we have here the coordinate y bar to the center of the composite area. We need to add these two q's. Okay. In order to find the centroid coordinate, we add these two, Q1 and Q2, and we divide it by the total area, which would be 2.5 plus 18 divided by 11, and that would be 1.8636 inches. Because we can see that the shape is symmetrical, the coordinate of the x would be the coordinate of the y. So we can assume that. Great. Now, we need to find the coordinates of the centroid with respect to the axes 1 and 2 that are given to us. Okay? In order to do that, we need to subtract these coordinates from the axes that are given to us. Okay, so let's go to the shape. Axis 1 and axis 2 is this. Okay, so axis 1. Okay, so now we need to calculate D1 and D2 for area 1. So because this is going to be the point where we're going to take the product of inertia from, we need to, and we know that the product of inertia of this shape about its centroid, you know, it's 0. The distance from this centroid to, well, from the x coordinate of the centroid to the x coordinate of these would be x bar minus x bar, that would be this, minus half, well, the coordinate of the x of this shape. That would be this. 0.5 minus 1.86, 1.3636. And it's negative because it's to the left of this origin of coordinates. That would be the new origin of coordinates. And the center of these would be 3 minus 1.86, 1.13, a little bit higher. This shape doesn't illustrate it really well, but this C should be a little bit around here. Anyways, so now that we have these two coordinates, we can find the product of inertia using the parallel axis shift about the axis 1 and axis 2. This is going to be immediate. Okay, perfect. About the center of the shape is 0 plus the area 1, that would be 6, that would be the area that is vertical, times the first coordinate times the second coordinate, well, times the first distance times the second distance to the centroids, and we have this. Now we do the same but with the other area. We find the distances, which in this case would be 1.63 and 1.36, positive and negative. After that, we find the product of inertia for the second area. That would be this, the area 5, that is the horizontal area, times these two distances. Alright, and at the end, the last thing we need to do is add the two products of inertia to find the product of inertia of the composite area, which would be negative 20.5 inches to the fourth. And that would be this problem. Thank you so much.